Risk, trust, and digital identity. So how to think about risk and trust under the same umbrella. So let me figure out this clicker situation. Wait, sorry. I do algorithms for a living, but I can't figure out the clicker. There you go. Okay, sweet. So that's me. I'll spend a bit of time giving my talk about my background, saying why I'm here because I think it's relevant for the overall story. I'm an electrical engineer by training, a computer engineer in grad school. So I went to McGill, I went to U of T for grad school, and then I worked at Capital One as a data scientist for a few years, working in a bunch of areas. I see like a lot of very banking heavy audience today. I worked in multiple areas from originations to authorization. So I led the high risk authorizations team before leaving there. Then I worked at a startup, at a buy now pay later startup for a bit, as a data science manager in fraud there. And then I moved to one of the coolest experiences that I've had was a company called Jumio. I feel that given the type of audience that I see today, a lot of people kind of like if you know Jumio, but you've definitely used that service. So if you've ever taken a selfie to authenticate anywhere, and then a picture of your ID, and then basically the algorithm to match it. So I built that algorithm from scratch and got a patent for it during my time at Jumio. So I work with companies such as Coinbase, that's why it's there. If you create a Coinbase account, you take a selfie, you take a picture of your ID. Same with Airbnb. We had a very large variety of customers there. So it went from like MasterCard and HSBC, they were one of our biggest customers, to company and like Coinbase as well, all the crypto companies you can think of, to things like OnlyFans and like Bet365. So how can you build an algorithm for all of those companies that still makes sense, and you can explain to them why you accept or reject someone, while their use cases are still completely, apparently different, like visually on the surface they look very different, but actually they're a lot more similar than you think, right? So when you take a selfie, you're just like, okay, like that's I'm just taking a selfie and they're just comparing my face to my face. But in reality, there's like a lot of things that go under the hood, right? So it's you look at what kind of device that person has. Can you build a device fingerprint so that you can identify what kind of device is under that? What does is the face covered or is it not covered? To Olga's point earlier today on like what things where AI can go wrong. Many times we got like customers saying that, for example, if you you can trick the AI on things that are not representative of the overall distribution. So for example, if you have a face and then you have like, you put like, you know those glasses that have like fake eyes? Like those little things can like really trick the AI. So it's like thinking of all those corner cases. One of my favorite examples was a big crypto company. I'm not gonna say the name, but they had a fraud attack. It was coming from Vietnam. It was people were lining up at a market in Vietnam, and basically what they were doing is that they were giving like probably money. Yeah, that's what I'm guessing to people to take their selfies. What I saw though was that if you were taking the selfie, the background looked like a bathroom in a market. And you can actually see from some of the pictures, you can actually see the like a line of people. So the actual IDs were legitimate and the actual faces were legitimate. So from that standpoint, everything looked fine, right? Like the person matches the ID. But then how can you look at other factors? Because what they were trying to do is they were trying to get the referral bonus, for example, for opening an account there. So it's like, what other factors can you do, such as like maybe like a background detector, right? But in many cases, the backgrounds are very similar. So are you only gonna reject based on that? So how to build a system that can basically tell you, hey, well, maybe the repeated background alone isn't a very strong signal, but the background and the face and the type of ID, the type of customer can really tell you many things about it. So Fast forward. Again, that was one of the that's what I'm going to talk today, which is how do you think of risk and trust under the same umbrella? And the other part is the second patent was on API workflows, which is basically if you think of a company like Jumio, that we sell data as an API, but we also consume data. Well, I'm not working there anymore, but I don't know why I'm still saying we, but at Jumio, they were like, it's companies that also consume data from other third parties. And basically, it's like, what is the right amount of APIs and right amount of information that you need? And like which API comes first? So for example, if I already know that your email is very sketchy, do I really need to go any further, right? Do I need to call the other third parties? If I already know that your phone number is blacklisted, do I really need to go elsewhere? If I already know that your device itself is really sketchy, do I need to go elsewhere? So all to say, that's a bit of the background. Fast forward, I'm working at I teach a course at the University of Toronto in AI in finance. It's like a intensive 6-month course, and I work at Pinterest. And what I do at Pinterest is similar but also different. It's similar in the sense that that I am able to reuse all those algorithms and blocks of code that I've used in the past, like conceptually. And what I'm building now is predicting quality. So what takes you, as Pinterest is trying to go into more deeper into shopping, that if you go like, oh, this is a really cool like living room, where can I buy this couch? And if you click on a link there, what makes you trust that link? So it's less about whether the link is actually legitimate or not, and it's more about what makes you trust it. So what needs to be true for you to say, okay, I'll put, here's my credit card, take my money. It's like that step. So honestly, when I was hired, I was like, wow, like how am I gonna translate? Because I was used to a very credit heavy world where you either pay or you don't. And then like fraud is a little bit blurry. That it's like some cases go undetected, but it's still like you're either a fraudster or you're not for the most part. I mean, again, there's a bigger gray area. But then for something like quality, right? Like the perception of building an aesthetic score, like what's something pretty, right? And it's like there are a lot of what's something pretty on Pinterest, and it's like what you see in Canada is different than what you would see in India, that it's different from what you see in Brazil, because there's lots of very cultural components associated to that that basically determine what quality is. So that's I hope that kind of makes sense. I am expecting a lot of questions, so I will leave a lot of time at the end for Q&A. But basically, I want to talk about that. How can we think of all of those problems with under the same umbrella, like using honestly kind of the same the code base. When I got the patent, honestly, I was like surprised that they didn't even want to patent it, because it was like I just combined a bunch of like research papers into one, but they said that the way it was combined was unique. So I guess like I was like, okay, I guess that's how people patent things. But also say it's very interesting how I've seen like with time the value of like really investing into solid infrastructure, so like code bases, kind of like know what you do really, really well for 1 or 2 use cases, and then you can reuse that tool set and expand it to a large number of cases. So let me go to the next. These are kind of like the main items here. So first one again is like how we can frame similar problems under the same umbrella. How can we optimize based on costs of mistakes? So if you think about this, the cost of declining, for example, if you have a credit card, the example that I give all the time is your credit card loan is, let's say, on average $5,000. Your cost of a false positive being you wrongly declined someone. You said, okay, they were fraudsters. They were not going to pay me back. What's your opportunity cost there? Okay, let's say there it's like $500. But if the cost of a false negative is a lot higher, because a false negative is, well, I actually let someone in that was actually a fraudster. What they're going to do is they're going to wipe your credit line, right? They're going to take your $5,000 instead of your 500. So how can you embed that relative risk tolerance between the cost of a false positive and a false negative, and also adapt that to something like, for example, Tinder in Japan was one of our customers that we had to build algorithms for when I was at Jumio. And Tinder in Japan really cares about being above like 18 years old, for example. So again, the cost of a false negative there, saying that someone was fine and like they slip in, can be a very, very high regulatory cost, right? So it's like how do you treat your score? How do you treat your risk score? And if you have the same score, where do you draw the line between all those thresholds? So what we're going to talk about today. And the part 3 is how can you use that framework for automation? So can you automate any of those, like how much can you automate? How do you automate it? And how can you decide what's the optimal risk tolerance that you should have? And the last one is input data sources. So how can you go above and beyond what you have on your current data set, and how can you invent yourself like data sources with things that you already have? So things that I'm not gonna give details, but if you think about all the data that can be used just from the orientation of your phone. So for example, if you're gonna be again going back to the background example, right? We were trying to build a model for whether to see something was a picture of a picture or an actual picture of someone, you know, because many times like people take pictures of an ID, they print out a picture and they take a picture of the picture pretending it was a selfie. But if the orientation of your phone is like this, well, that's very unlikely to be a selfie unless you were like this, right? So it's like, how can you be creative with current data sources that you have, and instead of going like deep into the kind of like the pixel, the different gradients between the pixels and the images, just think of kind of like beyond the box of like how people are actually using your product. So, so I kind of went over these, but I'll just for the sake of completeness, I'll go over them. So how can so capital 1, how can we avoid accounts like account takeover basically? So if you want to avoid sending the accounts to credit cards to the wrong people. Uber is like, how can we make sure that the driver is who they say they are? So for example, Uber really cares about the verification of their customers. They were also our customer. Airbnb, again, like how do you make sure that the referrals are exploited by actually different people, and it's not just the same person like opening multiple accounts? And at Pinterest, how can you make sure that a merchant actually delivers their products, and that those are the ones that are getting distributed? So we're going to start structuring this a little bit more. So we're going to bring all this stuff that is a little bit everywhere, and we're going to bring it into the motive, which is like, why do people do the bad behavior to begin with? So which is going to be that, and the definition of bad is like, what are we trying to solve for? What are we trying to detect? What are we trying to predict? So the same, if you know, it's kind of like the same way of thinking about a Bernoulli trial. So a Bernoulli trial is basically when you do like a coin toss. So it's, you say like whether you get a like head or tails for a specific coin toss, and even though that specific use case is very limited, Bernoulli trials are used to whether you clicked or you didn't, whether you paid or you didn't, whether you blah, 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 or you didn't. So it's like, it's all about using a very common framework and reapply that to multiple areas, right? So there's a credit card example I was talking about. So going a bit deeper, the example of a credit card company, you have definition of a false positive. I thought it was a fraudster, but it turned out it wasn't. The cost of a false positive is, okay, let's say $500, which is the lifetime value of a customer. Definition of a false negative, I thought it was fine to approve that customer, but it turns out it was a fraudster, and the cost of a false negative which is, let's say, like the average credit line, let's say $5,000 that a customer can max out, right? So how can you, this tail gives me a ratio of actually my break-even point between these two is for every 10 false positives, I can get one false negative, and that's where basically my risk tolerance equals each other. So this is what typical distribution looks like. These are all my drawings. I'm sorry for that. I'm sorry about that. So we want a risk score that allows us to classify users based on the treatment. So this is what the model will actually output, which is the risk level here, or the risk score. But the way you read this is like, okay, most users are good, and some users are bad. So you want to build a score that gives you this shape so that you can like cut it here, and you say, okay, from here to here, you're bad. From here to here, you're good. In reality, it's tricky to find a threshold that will tell us where to draw the line between good and bad, and that's where the ratios that I was talking to you guys about come in. Again, you can have, in many cases, it makes sense to have like a low, medium, and high risk bucket, and you treat them differently. So for example, maybe if you have a little bit of suspicion, but not that much suspicion, it doesn't make sense to go through all the checks that you currently have because it's more expensive. So it's a resource optimization problem that it's like, well, I'm only gonna really, really, really dedicate my resources where we actually have to. And on the areas where it's actually lower risk, this can be, less checks are required. It's more like, okay, let's just give it a second look. If we go a bit deeper here, we're like, okay, I actually feel pretty comfortable about this area here. I'm very, very confident these guys are bad, and the precision and recall I get there, and after all my audits, I'm actually very, very confident that I can decline them. Likewise, I'm very confident I can auto-approve these ones. So as your model evolves, the idea is that how can you shrink this area from the left and from the right so that this gray area that you're dealing with gets smaller and smaller over time. Realistically, I don't think it ever gets to 0, and I don't think it should get to 0 if you actually want to make sure that you understand, continue to sample and audit your distribution. But again, obviously, you want to shrink that to the best of your ability. So this is just an extension of the previous one, but it's something. It's simple in the sense that well, you want to say, okay, if you're in this dark green area, if the score is less than some threshold, then I want to auto approve. If it's in between, I want to manual review as low risk, with less checks as the medium risk, and then less checks as the high risk. And if you're too risky, then I'm just going to auto decline you. So the devil's in the details. Getting a great risk score is not easy, right? The output risk score, the quality of your score, is meant to be, is a function of your input data, as Henry was saying, and also the model hyperparameters, right? And how, like, it's not just it's the data, but it's also what model you're using for it, and what infrastructure, and how you're implementing it. Back to Olga's point. So this diagram is, I know it's convoluted, and it's meant to be that way. It's meant to highlight the richness of data that exists out there. We enter a bit more sensitive topic in terms, because it really touches a bit about on the ethics side. For example, a lot of my friends were telling me, like, well, how do you feel like a company like a data aggregator, that Jumio, that has like all the data in the world for hundreds of countries, for a lot of companies. I mean, I think there are like pros and cons to that. I think the pros is that right now you get your account stolen. Who do you go to? You have no one to complain to. You have like no one to like go after. And if you had a centralized company, then at least you can go and tell them like, hey, like this wasn't me. You have my face elsewhere, so you definitely know it's me. You know, you have my device. You know me. But it gets tricky, right? Because the big and only the big if there is like, it has to be a trusted entity, and trusted is a very, very like big word. So Anyways, these are things that these are types of data. These are not specific to any company. These are just variables that I've seen across multiple clients, across multiple companies throughout my career and even in academia. So that you have traditional data sources that bankers love, such as like income, your zip code. I don't know if zip code is still allowed as a data source, but I know there are like all sorts of tricks around that. What kind of product it is, like are you applying for like a mortgage? Are you applying for or are you like small, like if you all the credit cards, for example, are you applying for a secured line? Are you applying for an unsecured line? Is it an underserved market, like upmarket type of data? Alternative data sources, I think that's what it really gets cool personally. One of them is email data. So how old is your email? What does your domain say about you? What does your IP address say about you? The network, the geo data. There's a company called like GeoComply that they're doing really cool stuff. They're based out of BC as well. That they are the ones, they like Amazon Prime, Netflix, and all of them. They use them for basically making sure that people are using their products in the right geolocation. EXIF data, you might not. It's not very common, but that's basically all the information about a picture. So if there's any picture, you can tell what kind of camera it was taken with the pixels. You can tell like all of that stuff. And again, all those variables individually don't really tell you the story, but if you start combining all of these like weak learners that we call them, like they can become a very, very powerful story, right? And there's things like cyclical variables. I think one of the quick wins that I've seen in the past is that to boost model performance, if you have like your things like the day of the week, your holidays, the hour of the day, the month of the year, those are very like cheap and free variables that people underuse. And in machine learning models, they usually don't encode them the best way. So they would do like one-hot encoding, if that means anything to you, or like label encoding, but they don't really use like the cyclical aspect of it. So for example, if you do something like label encoding, you have that 11 to 11, for example, from 11 to 12, there's 1 hour difference, but from 12 to 1, the model is going to think that there's 11-hour differences, but in reality, it's just as far 11 to 12 as it is from 12 to 1, right? So there's that cyclical component, and our lives are very like seasonal. So if you know that, for example, if someone is applying for a loan at like, I don't know, like 6 p.m. on a Wednesday, like after work, has a different level of legitimacy than if you say you're Canadian and you are in, I don't know, like in Croatia at like 4 a.m., even though your language is like Hindu or like Chinese, and you know what I mean? So it's like having all of these elements that go way beyond the classic variables. I can go back, sorry. There you go. And so that's one thing. And the other part that I also think is really cool that I would actually kind of encompass it with the sorry, my bad, don't hate me. The alternative data sources is the device data that I was talking about. So it's like using your accelerometer, gyroscope, network data, etc. And all of these can get you your output score. So for now, I have this is the end of this, but I actually do have an appendix that I'll leave because I'm waiting for questions that I think you guys are gonna ask. So it's basically about like going through how to actually find those thresholds and like different methodologies for that. But that's only if there are questions. And that's it for me.